Welcome back to our case study on Prairie to Corn. We're on page 3, and we're dissecting this very dense paper, or what will become a very dense paper, in a short bit. So we're now entering more of the scientific writing sections. And before we even start reading anything, there are some big things we need to just look at on this page. So one, we have the title, so I guess we do have to read. Second, we have pictures. So Part 2, carbon in prairie grasslands and plowed cornfields. So we know that we're after carbon at this point. And let's zoom in on the photo. All right, our authors provide us images of soil. We have an A and a B soil. Both have some sort of measuring device dropped down in them, it looks like. So B has a tape measure that starts right about there. And A, you can kind of generalize, and maybe it's right about, I don't know, I'm being generous. So not identical. I also see that the measuring device on B, it looks like they've zoomed in a little bit more. You can almost see the numbers, almost. Let's go back to A here. I'm going to take a look at A, and it differs from B because the soil changes color very little in A. So it's very dark here, almost like a black-blue color, very deep into what appears to be an open hole. And I'm drawing a line towards the bottom, the lower portion of A, kind of where I see where it goes from the top is more of a dark black color into a lighter, more coffee color brown. So this is what I'd call a coffee brown, maybe down here. And this one I'd call maybe black. Okay. All right, B, if I'm looking at B now, I don't know. I'm kind of looking at this light brown. And below that, that's when I get into a darker brown. So already I have some bigger differences. Down here at the bottom of B, we might have that coffee brown type of color. Maybe, if we're being generous, I can kind of see a little pocket of it right here. So I might be splitting hairs. We'll see what the authors try to tell us. Reading the caption, soil profiles from A, an undisturbed grassland, and B, a field cultivated with a plow. So A would be our prairie, and B would be plow. All right. Give some nice sources here. Ecological Society for America. That sounds like it probably is a peer-reviewed journal, probably prestigious, so that they allowed this in as evidence. I think this is a reputable source. That would be what I would be concerned about. Now we're actually ready to tackle the reading, now that we've looked at these soils. The potential pool of carbon stored in soil, so I'm looking right here in this first paragraph. The potential pool of carbon stored in soils can be quite large, depending on environmental conditions and how the ecosystems are managed. In fact, on average, the soil carbon pool is thought to be about twice the size of the atmospheric carbon pool. Whoa, that's a bold statement there. Sounds like something I should take note of. So I'm going to take note of this. And if I had to kind of write this in a mathematical statement, I would say we have a carbon pool. So if I let one little box, a gray box with a C in it, equal one carbon pool, we're going to have a soil carbon pool and an atmospheric carbon pool. So I'm setting up my soil pool, and my ATM is my atmospheric pool, carbon pool up there. So the author tells us, in fact, on average, the soil carbon pool is thought to be about twice the size of the atmospheric carbon pool. So I let the soil pool have 2 blocks of carbon, so considering that's twice the amount that the ATM or the atmospheric pool has, atmosphere only has 1 carbon. So if I wanted to set this up, excuse me, as a formula here, I would probably say these together equal total carbon pool. So that would be 3 blocks total for that one. So our final equation would look thus. Let's go on to our second paragraph right here. So our second one, soil in an undisturbed grassland tends to have a dark, rich layer of organic matter called the A horizon, which can be a meter deep or more. So figure 2A. So here is our figure 2, and here is our image A. Yeah, that does kind of look like it's really dark. Now, if you don't know what an A horizon is, please go back and review the Bozeman science video that we had on soils. So it gives you the different soil horizons. A horizon is the one that we're most concerned of here, which it's a meter deep. It has a top of mineral soil layers and then bedrock surrounding it here. So it's kind of a sandwich type of situation. I'm going to say this is kind of the end of an idea, and I'm going to put a green double line to this. So in my way of reading, a lot of times, I'm going sentence by sentence. This was the end of an idea. So this was my A horizon here. Next idea here, next sentence. So we'll put a line here, realizing that we're breaking this area away. The second sentence after that, the carbon-rich organic matter in the A horizon builds up over a millennia. Ooh, that's a long time. As living organic matter dies and is decomposed or broken down by microbes into smaller and smaller pieces. All right, so we will put long time here, and that's the end of that idea. All right, I'm going to change my pen color because I like to do that when I'm changing sentences too. Yes, I do have many pen colors. Soil organic matter is 50% carbon. Wow, so if all of this black soil here is compacting over a millennia, we have a lot of carbon in it compacting over and over and over. Over time, some of these small soil particles, less than 2 millimeters, so I want you to appreciate 2 millimeters in a moment, in size, these soil particles are bound in water, stable soil aggregates. So big chunk right there, water stable soil aggregates that protect them from decomposition. All right, that's the end of an idea here. What did we just talk about here? So over time, we have some little 2 millimeters, so I want you to think about a centimeter. Centimeter, to me, is about the width of the tip of my pinky. And I know that's kind of a rough ballpark there, but that usually works for many people. So if you think about that being 10 millimeters, so 1 centimeter, the width of your finger, width of your pinky, 1/10 of that would be 1 millimeter. 2 millimeters is about the head of a pin. One of the larger kind of stick pins. Or it could be, take a look at your writing pen. It could be the width of maybe the ink cartridge that's in it. So you get these little beads. They're bound, they're water stable soil aggregates. So aggregates means a collection of things that all group together. And these little balls are in the soil, and they're actually protected from decomposition. Let's learn more. Changing pen colors because we're changing ideas. Black carbon pieces from historic fires are slow to decompose and are frequently bound in prairie grassland soil. Okay, that's nice. Campfire. Charcoal. Charcoal carbon. I've run out of space on this page. Let's move it down. Finally, recalcitrant organic polymers called humus. So another special word right here, humus, which are not easily decomposed by microbes, accumulate in the soil. I love the verbiage here. Recalcitrant. Finally, recalcitrant organic polymers. Let's break that down. Recalcitrant by Merriam-Webster Dictionary. Recalcitrant is obstinately defiant of authority or restraint, not responsive to treatment. So recalcitrant, that's an interesting word choice, but I think rather colorful. Organic polymers. So organic meaning having carbon. Polymers are long chains. So if you have something that polymerizes, it means that it gets sticky, kind of sticks together and forms a chain or even a net-like structure sometimes. But it glues itself together. So we have some obstinate organic carbon strings or net fibers of things. It's called humus. I would like to call it hummus. That sounds rather delightful to eat, but it's humus here. So we have these kind of webs which are not easily decomposed by microbes, so we can't chew these up and make them any smaller, and they accumulate in the soil. Since these are organic, they're mostly webs of carbon. Okay. Soil in the field cultivated with a plow tends to lack the dark color seen in prairie grassland sod and has much less organic matter, figure 2b. So yes, I agree with that statement. The dark color, nope, it's gone away. We have lost it right up here. Soil tends to be more easily eroded and has poorer soil structure. So when we talk about structure, we're talking about how well does it stick together. And if you look at this topsoil that I just circled, that drier topsoil, if you were to pick that up in your hand, you'd be able to sift it through almost like a sand, and it falls apart quite easily. When you pick up the darker soil in A, that tends to clump together. You can kind of mush it between your fingers. And we do this thing with soil called ribboning. So if you take soil in your hand, kind of like a little ball, and you push it, make a Play-Doh snake out of it. So think of when you're playing with Play-Doh last. I don't know, I play with Play-Doh a lot with my kids, and if you push it between your thumb and your first finger, kind of push it forward, you can actually make a ribbon or a snake out of it. And if it sticks, we consider it a little bit more tacky, maybe a little more liquid, and a lot of clay-based soils will stick more. Sandy or drier soils will fall apart, they'll crumble. So we call it the hand, or the texture of the soil, and that gets into the textural triangle, which we also touched on a little bit in class, especially with those soil layers. All right, we're ready to move on to our questions now. I'm going to tackle the questions in the second part to page 3, movie.